All right, 2017, number 4. The chemicals in clay used to make pottery can differ depending on the geographical region where the clay originated. Sometimes archaeologists use a chemical analysis to tell where it originated. We've done this for 3 different sites and 3 different chemicals. Question A. For chemical Z, describe how the percents found in the pieces of pottery are similar and how they are different among the 3 sites. So we have chemical Z at site 1, chemical Z at site 2, and chemical Z at site 3. So when we're describing distributions, we're thinking 3 things. We're thinking shape, center, and spread. Shape, we can't really tell because they're box plots. They all look symmetrical. Center, they all appear to have the same median at about 7, if you want to include that. And spread, there's a couple things that we could do here. So like obviously site 2 has the least spread and site 3 has the most spread. But what language are you using to talk about that? Range, IQR, standard deviation. I wouldn't use standard deviation because we can't really tell that. So we're kind of on range and IQR. Range is the one that varies at all of them, right? Site 3 has the largest range. Site 2 has the smallest range. IQR actually appears to be the same between site 1 and site 3. So probably use range as a better thing, though you could certainly talk about both, and that wouldn't be bad. B. Suppose, all right, let's write that down. A. Shape appears to be symmetrical for all of them. Median appears the same for all sites. And range is largest at site 3, smallest at site 2. B. Consider a piece of pottery known to have originated at one of the 3 sites, but the actual site is not known. Suppose an analysis of the clay reveals the sum of the percents of the 3 chemicals is 20.5%. Based on the box plots, which site, 1, 2, or 3, is the most likely site where the piece of pottery originated? Justify your choice. All right. So let's do kind of a rough check. So we're looking at the sum, right? So if that's like 7 and 13 and 7, 7 and 13 and 7, if that's 6 and 3 and 7, and that's 6 and 7 and 7. So this is 27. This is 16. And this is 14 to 20. So here's kind of where I disagree with the answer key. Since all of these are like symmetric, all of these distributions are roughly symmetric, and we expect them to be, I mean, not necessarily normally distributed, but like not weirdly distributed. This should be enough. If you only go from the medians, they only give you partial credit for it. What they really want you to do is rule out, say that it can't be from site 1 or site 2. You should look at the minimums, show that 20.5 is less than the minimum at site 1 and greater than the maximum at site 2. but like, it just says most likely. And I think this shows that it's most likely, but it doesn't like rule out site 1 and site 2. It just shows that site 3 is most likely. And so I kind of disagree with the answer key here, but you know, you can always do a better job, right? This was kind of our first rough look, and it showed that site 3 was the most likely, but how much more likely, I guess, is the question that we're answering now. So let us go into a little more depth. All right, so we'll show that this, whoa, what the heck? Okay. So we'll have 6, and we'll have 11, and we'll have 4, and that's 21. So the one with the smallest possible sum from site 1 is 21%. The one with the largest possible sum from site 2 is 7 and 4 and 8, and that's 19. And so it couldn't be from site 2 either, so it must be from site 3. And this does a better job of showing that it's much more likely that it's from site 3. But it's like, I thought we'd shown that it was more likely already. So for B, max, min, let's start with min from site 1 is 6 plus 11 plus 4. Max from site 2 is 7 plus, which is 19. And then we should probably show that it does fall within the range of site 3. That's 5 and 6 and 3, so is 14. Max from site 3. Which was 5 plus 6 plus 3, is 7 plus 8 plus 11, is 26. So 20.5, only in the range of, for whatever, of site 3. All right. For B double I, suppose only one chemical could be analyzed in the piece of pottery. Which chemical, X, Y, or Z, would be the most useful in identifying the site where the piece of pottery originated? Justify your choice. Here's another place that I disagree with how specific you have to be in your answer. But again, I'll point it out because they were very specific. It's chemical Y, right? The Y is up here at site 1. It's down here at site 2. It's in the middle at site 3, right? The rest of them, this varies, sure, but not by all that much. And for chemical Z, it doesn't really vary at all. And so, like, chemical Y, it varies the most relative to the standard deviation or whatever, which I think should be enough. But what the answer key actually needs you to say is that there's no overlap in the graphs. I disagree with that because, like, there could still be overlap and it would be the most useful. Like, it's not required that there's no overlap for it to be the most useful chemical. But in this case, like, there obviously is no overlap. in the percents. If it's between 11 and 15%, you know it came from site 1. If it's between 6 and 8%, you know it came from site 3. If it's between 2 and 4%, you know it came from site 2. Like, there is no overlap, and that's, like, it's extremely useful in this case because there's no overlap. But it could be the most useful even if there was overlap. So, I don't know. I kind of disagree with them there, but, like, yeah. So for C, it's chemical Y. Because it varies the most. Across the sites, there is no overlap in range.